So our steps are going to stay basically the same. It's just we're going to have to repeat some pieces. And in fact, so this is true for 2 radicals. This could be with an equation with 100 radicals. It's the idea that you just kind of keep repeating this one cycle until all of the radicals are eliminated. So let's kind of talk through these steps up here, but also go through an example down here. So our first step is to isolate one of the radicals on one side of the equation. Doesn't matter which one. I do typically choose the one that's messier, like this. Having this square root of x plus 72 alone, that would have been my choice to isolate rather than the square root of x, but in the end, doesn't matter because it's all going to solve to the same thing. So now that we have that one isolated, so we have the square root of x plus 72 alone on one side of the equation, we're going to square both sides of the equation. Now, when we do this, if it helps, expand this out to see that this is the square root of x plus 6 times square root of x plus 6. Because students like to change that into the difference of squares, and it's not. We're going to have 3 terms come out of this. So seeing it out like this, then you can be reminded to FOIL. So we're going to go first, outer, inner, last, and simplify from there. On the right-hand side of the equation, we have just a radical and exponent, so that's going to be x plus 72. Notice on this left-hand side, that square root that's over x cannot cancel with that exponent of 2. And it's because of that addition bounds those numbers together, so that's where this becomes a binomial. Whereas on the right-hand side, everything's under that square root, so there that square root can cancel with the exponent. Alright, written out in the long form here, let's FOIL. Square root of x times square root of x plus 6 times square root of x plus 6 times square root of x plus 6 times 6, which is 36. So, to simplify, square root of x times square root of x, well, that would just leave us with x. We have like terms, and you could think of this as the same thing as taking 6x plus 6x, then it will be 12x. The only difference here is that x is trapped underneath the radical, so that's going to turn into a plus 12x, square root of x, sorry, since we're just adding them together, and then plus 36 equals x plus 72. So that takes care of step 2 of raising both sides of the equation. Then what we're going to do is repeat those first 2 steps. I'm going to isolate one of the radicals, and I just have one radical left now. I'm going to isolate that square root of x. So what I could do is subtract x from both sides. Could also subtract 36 from both sides. So what that will leave me with is on the left-hand side of the equation, we'll have this 12 times the square root of x, and then equals, well, x minus x will just turn into 0. 72 minus 36 is a positive 36. And then we'll divide both sides by 12, and then I'll have my radical isolated with 36 divided by 12, which is 3. Then I can do step 2 of raising both sides of the equation to an exponent. And when I do that, square root of x squared is just x, equals 3 squared, which is 9. And then I need to check my answer. So what we'll have here is the square root of 9 plus 6. And I want to see, does that equal the square root of 9 plus 72? So square root of 9 is 3. 9 plus 72 is 81. So we're seeing 9 equals 9, which is correct. So x equals 9 is our solution. Alright, another example here. So isolating radical to one side of the equation, which we have on this left-hand side. And what I'm going to do is square both sides of the equation. So on the left-hand side, that's going to leave me with just x minus 4. On the right-hand side, I'm going to have, again, if it helps to see it, as square root of x minus 2 times square root of x minus 2. Write it out in that form. So square root of x times square root of x is just x. We'll have this negative 2 root x minus 2 root x, and then negative 2 times negative 2, which is positive 4. And then I'm just going to combine like terms with that negative 2 root x and negative 2 root x, which would be minus 4 root x. And then what I want to do is isolate that square root of x. So I'm going to subtract x from both sides of the equation. I'm going to subtract 4 from both sides of the equation. So x minus x is 0. Negative 4 minus 4 is negative 8. And I would be left with a negative 4 root x over here. Divide both sides by negative 4. And that'll give me a positive 2 equals the square root of x. And then we're going to square both sides. Now give me x equals 4. And then we just need to check our answer. So, with this, we have the square root of 4 minus 4. I want to see, is that equal to the square root of 4 minus 2? So, square root of 4 minus 4 is the square root of 0. Square root of 4 is 2. And we're getting 0 equals 0 out, which is true. So x equals 4 is our answer. Okay, 2 more here. If you have this case of 2 radicals and there's nothing else adding, subtracting, multiplying, or dividing outside of it, then this ends up being pretty easy because all we're going to do is square both sides of the equation. And what will happen when we do this is we get this cancellation of radical and exponent on both sides of the equation. So on the left-hand side, we'll just have 4x minus 3. On the right-hand side, we'll just have x plus 3. And then we move everything with x to one side of the equation. So I'll subtract x from both sides. I'll add 3 to both sides. And I'll divide by 3 on both sides to get x equals 2. And then we just need to check our answer, which would be looking at the square root of 4 times 2 minus 3. And we want to compare that to the square root of 2 plus 3. So we'll have the square root of 8 minus 3. And does that equal the square root of 5? Which 8 minus 3 is 5. So with that, we have that equation balanced, so x equals 2 is our solution. Alright, last one here, and it's a bit of a big one. So, what we're going to see here is like if I had to isolate one of the equations, these are both equally messy, I'll call them. Whereas the other ones just had square root of x, which is great, and simplifies nicely. This is going to get a little trickier because we have expressions underneath both radical. But this is great to have this one isolated on one side of the equation. Perfect. So what I'm going to do is square both sides of the equation. Square and square. So on the left-hand side, and I'm going to go ahead and write this out in an expanded form. And I'm going to make sure we kind of go through this foiling slowly, because we haven't really foiled with a whole expression as one of the terms. Equals, and on the right-hand side of the equation, the radical and exponent just cancels, so that's just 4x plus 1. Okay, so simplifying this left-hand side, what we need to visualize is we have our first term and our second term. And we have first term and second term. So let's start with multiplying the first terms. So square root of x minus 2 times square root of x minus 2, when we multiply those together, all we get is what's underneath the radical. So I'm going to go ahead and simplify that. That's just x minus 2. If it helps, we can go ahead and put parentheses there. Then what we'll have is that square root of x minus 2 times positive 3. So I'm going to have positive 3 times that square root of x minus 2. So that's our first outer, and then we're going to go inner, which will be positive 3 times square root of x minus 2. And then we'll have last positive 3 times positive 3, which is positive 9. And then that equals 4x plus 1. Okay, with the x minus 2 and the parentheses just drop, so we'll have x minus 2. I'm going to go ahead and combine the negative 2 and positive 9. So let's go ahead and call that plus 7. And then here we have like terms. This is like 3x plus 3x. It would be 6x. It's just where I would have x. I have this whole expression here. So then we have this plus 6 root x minus 2. And all of that equals 4x plus 1. Alright, now from there, I'm going to isolate the radical of x minus 2. So I can subtract x from both sides. I can subtract 7 from both sides. So with that, I'll have 6 times the square root of x minus 2 equals 3x minus 6. We're going to divide both sides by 6. And depends on what you want to do here. I'm going to go ahead and reduce this fraction down, thinking of it as 3x over 6 and negative 6 over 6, just because especially that side would simplify nicely. So I'm going to have the square root of x minus 2 equals 3 divided by 6, which is 1/2, times x, and then negative 6 divided by 6 is a negative 1. Alright, so here we go for our second round of squaring. I'm going to square this side and square this side. And what we're going to see is foiling again over there. So on the left-hand side, we'll just have x minus 2. Over here, we'll have this 1/2 x minus 1 times 1/2 x minus 1. So foiling, half times a half is 1/4. X times x is x squared. Outer, negative 1 times 1/2, so negative 1/2 x. Negative 1 times 1/2, negative 1/2 x. And negative 1 times 1 for a positive 1. Now what I'm getting here is something that's quadratic, so I'm going to need 0 on one side of the equation. And I'm going to go ahead and combine my like terms there first. So a half minus, or negative a half minus a half, that would be a negative 1. I'm going to go ahead and subtract x from both sides. I'm going to go ahead and add 2 to both sides. So then we have 0 on one side of the equation with this 1/4 x squared minus 2x plus 3. Now, we have a quadratic, and we've got a fraction in there, and I don't want to work with fractions. But we have an equation here, and that makes it nice because what we can do is multiply both sides of the equation by the same number. And what I'm going to do is I'm going to use that denominator. I'm going to multiply everything by 4. 4 times 4 times 4. And then that 0 also gets multiplied by 4, which means that just stays 0. 4 times a fourth is 1. 4 times a negative 2 is negative 8. 4 times 3 is 12. And now I have something I can factor. So factors that multiply to positive 12 but add up to negative 8, that's going to be a 2 and 6. So x minus 2 x minus 6. So we're going to have x minus 2 equals 0, which gives us an x equals 2. X minus 6 equals 0, which gives us an x equals 6. And we're so close to finished, but just not quite, because we need to check those answers. Now I'm going to go up to the side here and check. So let's start with x equals 2. Square root 2 minus 2 plus 3, and does that equal the square root of 4 times 2 plus 1? So the square root of 2 minus 2 is the square root of 0. 4 times 2 is 8. 0 plus 3 is 3. 8 plus 1 is 9, so square root of 9 is 3. So x equals 2 works. So we confirmed that solution. And now let's look at x equals 6. So square root of 6 minus 2 plus 3 on the outside. And does that equal the square root of 4 times 6 plus 1? So square root of 6 minus 2 is 4. 4 times 6 is 24, and then plus 1. So this will be a 2 plus 3, and this will be a square root of 25, so we're getting 5 equals 5, which is great. So this is a case where we have two solutions. If we graphed both sides of the equation, what that would look like is having two intersection points on these graphs.